the green tick mark on the feedback button that you're back. That would be very helpful to me. Great, good to see you back. Okay, excellent. Now we're coming very much down to the end of this arithmetic review. Now, a lot of people find this one of the most grueling parts of the course in a way, partly because there's very little that we do to illustrate these concepts of fractions, exponents, and so on with real GMAT practice questions. And that's because, I'm sorry to say, real GMAT practice questions tend to be quite a bit more difficult than what we were just looking at. Difficult in the sense that they require a few more twists and turns along the way. So it's important that you get straight to work. You know, if any of this seemed less than straightforward to you, then it's important you devote some serious time to getting it to become second nature, really, so that when we actually get into looking at problem-solving strategies, that we're not, well, I mean, not saying that we begrudge the time, but that you're not spending too much time trying to remember what the basic rules of exponents and fractions and square roots so on are, and that those tools are sort of available to you and at your disposal. For most of the rest of the math content over the remaining 7 weeks of the course, we will be working much more interactively with practice questions. It's just, but here when we're working at the most basic level, it's just not possible. So before we move on to critical reasoning, which is what we're covering for the rest of today, I will just draw your attention to some further issues, some of which I've already alluded to in terms of what you need to know by heart in order to succeed on the test. And firstly, the multiplication table. It says here that you should memorize your 1 to 10 multiplication table. I would go further than that and say if you don't know your 15 times 15 multiplication table, then that's a little bit worrying, and certainly you ought to know all the numbers up to, I mean, I wouldn't say necessarily know your 20 times 20 table, but certainly know your, say, a table that's 15 in width and 20 in depth, let's say. Being able to do that arithmetic mentally is going to be of tremendous value to you. So please do make sure you take the time to make it happen. Decimals and fractions are laid out for you here in the materials as well, and we've already covered the perfect squares, and they're shown in 2 different ways here. One is to know what your perfect squares are, and the other is to know what your square roots are. There's a little note about notation here, which it can be important to be aware of. It has tricked many a person. If you have -1 squared, well, if there's no brackets, then that is actually equal to -1. If there are brackets, then that's equal to +1. If the -1 is inside the brackets, then it tells you to take -1 times -1, and as we know, 2 negatives make a positive. If the minus sign is outside the brackets, then that's telling you, well, do the exponentiation first, then, so 1 times 1, and only then apply the minus sign. If you're not familiar with PEMDAS, this is the order of operations, telling you do what's in parentheses first, or brackets if you learned British English, exponentiation, multiplication, division, addition, and subtraction in that order. So that, of course, is relevant to this. Exponentiation comes first, and only then the subtraction that you've got to do here. So this is just an addition issue that you need to be aware of. Powers of 2, also very important. I would suggest that you also want to be aware of your powers of 3, and I'll just bring them up very quickly. So any of these numbers, 3 raised to the first, 3 squared, 3 to the cubed, 3 to the fourth, 3 to the fifth, 3 to the sixth. If you see the number 729 in a math problem, it should immediately pop into your head that that's not just any old random number that's greater than 700. It's conceivable that there's an issue around that the question revolves around its value as 3 to the sixth. Okay. So other issues that you need to be aware of. the cubes and cube roots, and a form of notation called factorials. If you haven't seen it before, it's these numbers with an exclamation point. The exclamation point tells you that you're going to do some multiplication. So for example, 4 factorial is 4 times 3 times 2 times 1. I hope everyone can see that. Let me know by the chat if that's not visible to you. Other than the fact that I've done it in yellow, which obviously is not the most visible color. 6 factorial, which equals 720, is 6 times 5 times 4 times 3 times 2 times 1. Okay? All these numbers, if it's a number and then an exclamation point, that just means that number times each of the other integers descending down to 1. The only one that's a wee bit unusual and that you will need to remember kind of on its own account is the value of 0 factorial, which is 1. This is simply, I'm sure that some advanced mathematician can tell us why that's an essential part of math, but it does come into some of the math problems that we're going to be facing. Next week and the week after, we'll be covering the areas of math that these come into. It's called combinatorics, but it's just important to recognize the notation and know the values as you look at them. Okay, so